Thank you. So first of all, who likes the browser? Okay, maybe half of you. That's interesting. Let's have a look. So this wasn't the participation, so there's more. So first of all, this is about TensorFlow.js, and we could actually stop after this slide because everything you need to know about it is on this slide, and it's also screenshot, so I stole it. So it's not even my work. So TensorFlow.js, no, wait. Who knows TensorFlow? Okay, few of people. Okay, so TensorFlow is a machine learning library by Google, and it typically runs on like heavy machines that have good GPUs. And TensorFlow.js is like the sister or brother, or maybe like the child of TensorFlow, and it runs in the browser. And what you can do in the browser is you train your machine learning models if you want to. You use pre-trained machine learning models, or you deploy a model that you trained on TensorFlow before. And we will do all three things. Well, I did this, I will show this to you. That's TensorFlow.js, and this is probably the most important slide. But you may ask, I don't know, maybe you do, why would you even do this? I mean, any answers? Why would you do this? Why would you run machine learning in the browser? Yeah?
Client interaction.
Client interaction, right. Good. What else? Or is it a bad idea? It's also possible. Games, also good. What else?
Validation.
Sorry?
Some kind of data validation.
Oh, you mean someone types something in and then you validate it and then, yeah.
It's not corrupt or...
Good, also good, yeah. Okay, but first, you probably know that the predominant language of the machine learning, it's Python, but we don't do it. But first of all, this is for a good reason. So there's a large and mature set of libraries. It's pretty fast because it relies on C, code underneath of even Fortran, and it's a good choice. So I think I have a tough task at hand because for the rest of the talk, I need to answer the question. Maybe you didn't have the question before, but now you have it. Why? And this is the answer. So first, it's for education. So with the browser, you have something that is zero installation, that is accessible to pretty much everyone who's able to hold a mobile phone in their hands or who has a browser. And there's no installation burden. And then someone said this as well, concepts are much easier to understand when you play around with them, when you have interaction. And this is one of my first examples. I showed this last year, so I'm not showing it this year because I have more examples. But this is a thing that allows you to understand how supervised machine learning works. And it's a lot of fun because you train the thing by giving it different postures, and then you get a shaking dog, or you get, what else, a bunny or kitten. But not today, because we have other examples. And then there's this TensorFlow playground, which is not so like exciting, but it's very visual. Who knows this one? TensorFlow playground. Few people. What you can do with it, I'm not clicking on it because I have other examples. What you can do with it, you configure your neural network. Each of these is a neuron, and then you train the network to separate these two classes of samples. And you can play around with it, play with the learning rate, with the architecture of the network, and it's very good for learning. And this was the starting point for TensorFlow.js. It's not built with TensorFlow.js, but the people who built it said, okay, this is a good idea now, let's do it as a real thing. So the first demo that I'm going to show you is a visualization of machine learning while actually doing it. And this is a great thing, we are now in the education part, because while we train a model, we can see what's going on. And this is the first demo. Let's see if I can find it. No. This is it. This is the live running demo. And as I said, this is just my browser. So you don't see it's my browser because I was hiding like the menu bar, but you see it's just the browser. I just loaded it. It will also work in your browser. So nothing too special. And what can you do with it? So what you see on the top right is the MNIST data set. This is handwritten digits. It's a very old problem. And it's not about solving this problem because it's not completely solvable and a lot of people already did this. This is just to show you how machine learning works. So this is the data we loaded in the browser, no server, just the browser, and we can do things to it now. So scrolling down a little bit, you can show other example digits. They're always 28 by 28 pixels, and they look like this. We defined a model up there. I'm not going into details. We can start training. And something you always want to do when you do machine learning, or what you often want to do, you want to see how the model behaves, how well it does. And this is training in the browser, and at the same time, it displays the curves of accuracy. You want this to go up, and this is the loss, and you want this to go down. And there's no need for any installation, so if you want to try this, you can just do it in the browser, and you see all these plots. That's pretty nice. There's other things. Once we have trained the model, what you can do in this case is you evaluate it, and you typically do something like accuracy, and you just click on this and have it all in the browser, and this is accuracy per class. That means, let's have a look. So 0, very high accuracy, almost all the time it finds the right one, but then the 8, you see errors with the 8, and then maybe you want to know, okay, what kind of errors are these? And this is just a few lines of JavaScript, you see that? Not very much, to plot the confusion matrix. And the confusion matrix looks like this. You read it like, this is the one that the network predicted, and this is the real one. And now you can see, okay, let's have a look at the 5, for example. The prediction was 5, but it actually was a 3. And then sometimes a lot of zeros, which is pretty good, and sometimes not. On the diagonal, you see the right predictions, and the darker the colors, the worse the confusion. And this is, again, just a few lines, and then you can have your interactive machine learning project with this. And this is all done using TensorFlow. Better to say tensorflow.js. So this was the first demo. Do you like this? I mean, does it make sense to you? Who of the people who don't like the browser now would actually try this? Oh, really? That's okay. Then we can stop now. We can drink beer now. So that's the best I could hope for. That's really good. There's more. This is interactive Tisney, and Tisney is. This one is working on the same data set. It's, again, the endless data set. And without further knowledge, it separates the individual samples of the digits. That means in this space here are all the, what is it, zeros, I guess, and the black ones are the 8s. And this is also possible interactively in the browser, which is also pretty nice. Something you can play around with, and with no installation. It's also pretty cool. There's another way of machine learning, which is called regression. So this is not really like deep learning on neural networks for real, but you can still do something like you have 2 sets of dots, and then you place them somewhere, and TensorFlow.js draws a line through them. Which is not exciting at all, because linear separation is always, well, not so exciting, but it's also nice when you go to this link to show it to someone. How would this work? How would a single line separate 2 dots? Also nice. This one is pretty exciting. It's pretty new. It's about GANs. Do you know GANs? Just to give me an who knows GANs? 2 people. That's pretty good, because this is a nice sample to understand how they work. And this is the GunLab, and it looks like a picture, but it's not. It's an application. It's a JavaScript application. And someone said it's about interaction. And this thing is great because it can interact with it and then see how GANs work. But first, before I can tell you like how great the application is, you need to understand a little bit about GANs. So it's a little bit overloaded. Maybe I'll switch off a few things now, because it might be a little bit too much here. Oh no, wrong. Gradients also off. Okay, perfect. What you see on the right side is a distribution of samples that I preloaded from here. So you can choose the distribution. It's just random samples somewhere, more or less random. Now, what you're trying to do is make a machine learning model, which is the generator, this one here, learn how to fake this distribution, to create something that looks very similar to this one, but it's actually generated. And the way it is generated is that it uses noise as input and tries to turn this noise into this representation here. And this doesn't make a lot of sense in this case, because it's just a sample. But what people do with it generally is that they fake images with it. And you do it because you want to generate, I don't know, something more interesting, a variation of something. And I will have an example on the next slide. But this is just to explain how it works. So you have one part, this one here, that generates a distribution. And I will turn it on again. No, wrong. There it is. Sorry. And the purple ones are the generated ones from a random distribution. And they're not quite like the original one, which is good, because that's what you really want. You want a variation of this. And I will run this for a while, because it tries to make it a little bit better. You see it moving around. And then at the same time, you see gradients. And the gradients point in the direction where the machine learning algorithm, based on TensorFlow, thinks it should move the point to. And obviously, only for the generated data samples, you have a gradient, because the green ones, they're the real ones. And now it tries to make them like more realistic. And then, what does it mean to be more realistic? Because there's a second part in the GAN, and this is the discriminator, and this tries to find out if the generated data point is fake or not. So they're working against each other. That's why it's called adversarial. So GAN meets generative adversarial network. And they're trying to fight each other, and each one has a little bit of a loss, and then if they're doing really well, each of them would have like 50% accuracy. I think we don't see it because it's over there. And you see, it's not perfect. It should be around here, around 50%. But it's also not done yet. But that's the idea of a GAN. And obviously, I'm presenting this to you now. But if you played with it, you would really understand it, because you can configure all these parameters of the GAN. You can load other data sets up here, like this one. And you can also paint one, if you know what you're doing. I don't know what I'm doing. So, and then you could train the whole thing on your generated data points. And you can also tweak the parameters, if you really know what you're doing. So this is based on neural networks, and you see there's one hidden layer, 10 neurons, 2 hidden layers, 9 neurons. And you can change that and make it more interesting. And this is, I wouldn't know how to do this except in the browser, where all the machine learning also runs in the browser. And that's a pretty good example of this thing. Good. Going back to slides. Here's an example of such a GAN, and it's pretty cool because, well, you will see in a second. Do you know him? Who is he? If you read the title, you know he doesn't exist, so don't fall in love with him or something. He's generated from an adversarial network that was trained on a lot of celebrities, like people who are typically attractive. That's her. Also good. And then him. You sometimes see that the eyes look a little bit strange, often the right eye. But if I hadn't told you, well, I should have done the experiment, but I haven't. Now I messed this up anyway. So would you have believed that they are generated? No. I mean, they look good, they're attractive, but not like totally fake. And this is pretty cool, and this is based on the GAN thing that I showed before. Also nice. This is, to be quite honest, this is not something that you do. Probably you will never do this in your daily work. This is just a fun thing, right? But we will come to things that you can do with TensorFlow.js that are something you would really do for business. Okay, next part. So first thing, we educate. That's what the browser is good for. I hope you saw this. But now, maybe this is the weakest part, because you're probably not JavaScript developers, or are you? Who's a JavaScript developer? A few. Good. This is for you. For the others, well, you might get an idea. So it might be that you just like JavaScript. Maybe you don't like Python, or you need to embed it in a bigger application. And maybe you also need to write a browser application. Maybe you also like how JavaScript development works, but this is, if you don't like it, then you don't like it. So again, interaction with visualization and other browser features like audio and video. And we'll come to the video part. Okay, a little bit of code. I think I have just 2 slides with code, so bear with me for a second. Just like TensorFlow, there's a low-level API, and on that low-level API, you operate on the base of tensors, which is a fancy name more or less for arrays. And you can create a tensor, and if it wasn't for the const here, I would say it would be very hard to tell that it's not Python, at least for this example. So you create a tensor, one-dimensional, you create it from an array, and then you have a scalar, I think in English, and then you have these 2 variables, you add them, and you get a result. And this is, of course, typically not the level we want to operate on, but it also works with TensorFlow.js. And then you can get from the result, you get the data back, and you see this strange keyword here because all this works asynchronously, because it's actually executed on the GPU of my machine. And this is just for technical reasons. You have to wait for it until it executes. But this probably only makes sense to the JavaScript people, so you have to wait it. It just works fine, and then you log it out. And this is obviously the result. If you add 2 to each of these elements in the array, you get, obviously, this. And this is low level. You typically don't do this. But then there's also the high-level API. And who of you uses or knows Keras? Oh, good. This is good news for you. If you know Keras, you feel right at home, because it's the same API as with Keras, but it's obviously JavaScript style. So sequential model, same thing. You add a layer, same thing again. This is a little bit different syntax. That means add a dense layer or a fully connected layer with 10 neurons. And this is a convolutional layer. This is all real code, so it's not simplified. And you say, what is the input shape? This would match the MNIST data set. And then you have the model. You compile it like with Keras, same thing. You train it like with Keras, same thing. So it's all quite nice. Probably you don't even really need to understand JavaScript. And then once you do this, you can get an example like this in no time. I think it's even a tutorial on the TensorFlow.js side, where you get the MNIST data set and the curves that you saw before, and then you have a full application. And it might make sense to do this. If you're asking yourself, why would I even do this? There will be examples. So you will see them. So for me, the thing that I really do, the others, I don't do that much. But what I really do is this. I have a model I trained on the real TensorFlow, and I deploy it in the browser. This is the creator of Keras, François Chollet. I think that's the way you pronounce his name, but I'm not sure. And he says, the future is one standard deep learning API, like in his case, he might think of Keras, I think. And then he says, train it on the TPU, which is the tensor processing unit, which is really powerful. It's accessible to you using GunLab. Then you export it, and then you make it run on the server side like you would expect it, you can make it run on a mobile device, right? Mobile device. Or you make it run in the browser, and it even talks about embedded platforms. I'm not so sure about embedded platforms so far, because people tell me they're not that powerful yet. Anyone working in embedded systems? Automotive? Hugh? Powerful enough for this? Sorry? Okay. Good. But maybe it's possible one day. And this is not something, well, I think this is not even a week ago, or was it a week ago? But I think he's right. He's right with it. So how would you do this? Oops. Yeah? Aha. This is the slide I was looking for. So you train your model on a beefy machine, so like something good. It's having a really powerful GPU or many. And then you deploy it to the browser. That's the idea. And I did this. It's not super real, but it could be real. So this is adapted from something that's real. And this is a calculator for car risk insurance. So I can click on it. You can see it actually does things. Hopefully, it does. And it's a trained model. It's trained with TensorFlow. It has, I think, 2 hidden layers, quite a few neurons in that. And what you want to do is you punch in the speed of the car. 100 seems reasonable. Age is 47, that's my age. 10,000 kilometers per year is driven. So, and then you calculate the risk group. And you saw a little bit of a delay, but this scales super well because it runs on my machine. So this is not on a server. You roll it out, but just rolling out a static, really static HTML page, and all the magic works in the browser of the customer. And if you have a good GPU, this will be a little bit faster. If you have a bad GPU or mobile phone, it will still work. And this is really something that I'm doing. So this is something that actually works. It actually works when you use the Keras-style API for defining your network. If you don't do this, it will not work, or not well. Not yet. Not always. That's most fair. And then, let's change it. I don't know, 17. What is the risk group? What would you expect? Young driver? Slow car? I don't know. I really don't know. Let's see. Medium risk? Makes sense? Let's make people really old. Fast car. 150, is this fast? That's a fast car?
100 is quite fast.
That's still medium risk. That's amazing. That's astonishing. I don't know. But you saw, I think at a certain point you at least saw it had a green thing, but maybe the red thing is hard to achieve. Come on. I don't know. 150. No, okay, 120. If this doesn't work, I will just, there you go. Okay, a little bit older, the driver, the speed a little bit higher, and then you get a risk prediction. You could do it in browser, just online. Someone calls, I don't know, an agency, and they make a prediction just in the browser. So maybe that's interesting. Let's quit this. That's what I already told you. You have to convert your model to TensorFlow.js. And this may sound scary, but I will show you that it's actually not. And then you have to load your model in the browser. And this is, again, code, but I think it's not too bad. So this is the way you load a model. So it lies on your disk somewhere, or it comes from the network, which is much more much more likely. And you load the model, and then you have the model. So that's the one line of code. And then you call model.predict on a tensor, just like with the Keras API. You get the prediction, you get the data from the prediction asynchronously, and then that's it. And this is not like simplified. This is the real code that works in the application. And then how does this work? So I have no idea what this means, to be honest, but somebody who knows what that means says it's accurate. I think my take on this is it somehow pretends that it's a shader for something. I think I see the word shader here somewhere. And then it tries to, or it pretends on the graphic card that it's calculating some textures, And it's not really a texture, but it's like translated to this sort of speak that the GPU can do, like a graphic card, and then it's converted back, and then it's actually matrix multiplication that you need for neural networks. That's the best take I can take on that. Anyone who's familiar with WebGL or OpenGL or something, or how a graphic card works? That's both good and bad, because you can't like show that I have no idea, but I would have liked to know. But anyway, what would you say is bad about this? Apart from that, I don't understand it. What would you say? Why is this a bad thing? Yes?
Because it requires that GPU hardware in the client device.
Sorry, can you say?
Because it requires that GPU hardware in the client machine.
It requires the GPU, but I'm not 100% sure. I don't think you can buy any machine that doesn't have a GPU. Is that correct? Even your mobile phone has it. Is it correct? I have not seen any computer who would not be able to execute this stuff, but maybe that's a good point. But my point was that this is a little bit expensive because it's not quite natural to do it. So you translate it to something else, do it and translate it back. And this is just, for my machine, I have a GTX 1060, which is for a mobile machine, a very good one. And I trained a little bit, and it took all of the memory, 6 GB, which is quite a bit. And the load was around 30%, which was surprising. And I think it's because it needs to do the translation to the GPU, and then it might not be totally efficient. And this is backed by numbers that they presented on the TensorFlow Dev Summit. Let's have a look. So these are the numbers for TensorFlow, like the real one, like the server-based. And this is the GPU that they had. It's like the big sister of mine. It's better, but not by much. And this is the time it took for a certain network to do a prediction, which is fast, but that doesn't matter. The comparison matters. So this one is like, on a GPU, it's 20 times faster than on a CPU, on a good machine, as it seems. Now, this is TensorFlow.js. I need to look at it from here, because it's just too big. TensorFlow.js, same GPU, unfortunately 3 to 4 times slower than this one, but still much faster than the GPU on the server. And then the GPU is, well, almost 2 times slower than the CPU on the server. But it's still good. I mean, this is in JavaScript. This is using that strange shader trick, but it's still good. Typically, it's still totally acceptable in speed, but it's a little bit slower. Now, the good news is, from one of the builders of TensorFlow.js, that web GPU is, well, at least it has been kicked off as a standard. That means at a certain point, maybe in 1 or 2 years, there will be a standard for web GPU. That means those performance hits should go away, more or less. And that's also quite nice. 1 second. Something I have not mentioned before is, leave this out. This was the best graphic I had. So this is not soon, but you can also train with the same code on the server using Noches, which is the server-side implementation of JavaScript. And then when you do this, you can train on the same backends like TensorFlow can do this anyway. So on TPU, GPU, and CPU. That could mean, if you really wanted to, you write your training code in JavaScript and then do the training on the beefy machine with the same code and then deploy to the browser, and you're still in JavaScript. I'm not so much fascinated by this story because I typically just train in Python, and this part is not so interesting for me, but for others it's exciting. Okay, coming to the last part, which is a little bit more entertaining, and this is apps powered by AI. And this might be something that's maybe something you could start playing with, and this is, you have a pre-trained model and you just use it. And this is the interactive thing. Let's have a look. Because we just accidentally did this. Oh, wait. And this is multi-pose detection directly in the browser. And yes, you know what you should do. Maybe if someone stands up for a second. Someone who's visible in this. Oh no, it doesn't work. maybe it's too many people. I don't know how many people it can detect at the same time. Maybe at least the ones in the front. Sorry? Where's this? I don't see it. It's hard if you stand directly in front of it. Max pose detection where?
Halfway down.
Ah, 50. Now what? Oh, my fan starts spinning, and now it's up to 20, and the machine gets really hot. Maybe someone stand up, please do this for me. Someone in the middle. Ah, good. And this is a pre-trained model, and that means if you want to use it, it's extremely simple to do something like this using JavaScript, because in the browser it's very easy to turn on the camera. Maybe it's also scary, but it's also easy. And then you can, for example, what they did, you just draw these skeletons here, and you see the limbs. Not 100% accurate, but pretty good. Not quite sure if your legs are here. It's possible, right? I don't know. You're dancing. Quite good. But you also see that the face is recognized, and then also where the eyes are. I think the resolution is not good enough because you're pretty far away, but it's quite nice. But you could do a lot of things with this. You could like control something else. If you had a robot, you might be able to control it with this. But you could also do something else. People do melodies with it, like giving the shape of a melody, for example. Right now, it might be a little bit more of a joke than a real application, but I'm pretty sure someone will find something that makes a lot of sense. And this is literally not even half a page of JavaScript code to make something like this working. If you're not a JavaScript developer, maybe that's not good news, but if you are, then it might be. I pretty much like it. So let's kill this now. Where is it? Okay, face detection, and then also face detection with bounding boxes, and also who the people are, and as you see, with many faces. And this is again JavaScript. I'm not quite sure what you want to do with it, but maybe you have an idea. And that's always how it goes. People show what's possible. Other people say, that's what I need, or that's what I will pick up. And these people, well, it works quite well. This is for artists. This is meant for artists, or people who are not very familiar with JavaScript. So I thought it might be good for you as a target audience. And there are a lot of very, very simple snippets of JavaScript that you can use in the application. And I will demo 2 of them. I prepared this. Let's see. It always takes a few moments until the model is loaded, because it's a TensorFlow model, and then you have to load it in the browser. And this is trained on texts by Ernest Hemingway, and you can, well, I'm not able to go into the detail too much, but this has been trained on, as I said, on the text by Ernest Hemingway, and now it knows in a way how they work. So we can start a text, and it will, where? It should create something. Oh, wait, So I start typing, and down here, it creates a text of a certain length, 20, and it creates a text that it thinks it should look like something from Hemingway. I'm not entirely sure. Maybe I have to give it more context, or maybe a little bit longer as a text. Okay, so the first one is not bad, right? I like the day. Other things comes in my pocket, not so sure. That was the only way to burst badly. Well, what does that even mean? Maybe I should give it more context, or you give me the next word. The next word is 10. I like 10. No. Oh, did it crash? I like 10 o'clock houses. And then the stocks take the children with the beard and then go and okay, so I have to tell you one more thing. The temperature adds maybe a little bit noise or maybe not so much, and I can take the temperature a little bit down. That means it might be less silly, but also less exciting. You give me the next word, please. Can someone give me one more word? I like 10. Oh, good. Oh, scientists and Hemingway? Okay, let's try it. It takes a lot of time because with each with each character that I type, it regenerates all the thing. And you don't feel it, but I do. My laptop is very hot. Scientist. Is that correct? Scientist. Wait. Is that an English word? Old looking? that sounds like a haiku, maybe something like a Japanese poem or something. Okay, the important part about this is if you want to do something like this, it's probably hard to understand why you would do this for your business, but you can go to the tutorial to train your own model. Then you upload it to the browser and everyone can do it. Maybe, I don't know, a present for your husband or your wife or something. It's possible. And as I said, this is done for people who are not so big fans of JavaScript. It's a little bit code, but not that much, right? And it's also like all of the code, also the code that interacts with the UI up here. I have one more example, and it works out nicely with the time. And this is one more example because it uses, you can see it, right? So it's style transfer, and it transfers this here using, well, this one. It used this image, and it trained a neural network with this image, and now it transforms me into the style of this image. And this could be done with any other image, and there are also applications who can do this. And maybe, I think it would be hard to switch the camera now. Probably not possible easily. Give me one shot if I can't make it. No, it's not working. That's a pity. I thought I could switch the camera and then we transfer you, but it doesn't seem to work. Not entirely sure why, but that's the way it is. Too bad. What? I don't dare. Because of all of the cables, I don't dare to turn my laptop, but it's cool, so you have to look at me. So, but it makes me a little bit more beautiful. And this is also something, again, this is play a little bit, but maybe it doesn't have to be. That's your turn. Maybe you find something that's a little bit more business style or makes a little bit more sense. Okay. There's a lot of more inspirations on this side. And this is all like exciting stuff. This is probably not something you would use in your daily work, but it's fun. It's music, it's art, it's drums somewhere. And then there's, of course, there's a cat. Oh, another one. People like cats. We like cats. So this brings me to the final slide. We can wrap it up. So TensorFlow.js is for browser-based apps, and it can make use of any GPU. And if you know that TensorFlow, like the real TensorFlow, can only train on certain GPUs, which are typically very expensive, this might be interesting because no installation. You just use any GPU, get started very easily. You have zero installation. This might be especially interesting for education, but it might also be interesting as a story when you have a model and you want to bring it to the customer, which is really hard. For TensorFlow, it's not that easy. There are options, but they all have like their downsides. And this, for me, was a very good way of bringing my model to the customer. If you have a JavaScript application, it is super easy to integrate all the machine learning stuff with the rest of the JavaScript because it's just JavaScript calls. And the code is really easy. And then because the browser is very good for visualizations and then also interactive visualizations, it's also good when you want to show something, when you, I don't know, let the user do something and then that directly interacts with a machine learning. And that's what I also said, perfect for learning. Okay, thanks a lot.